All right, let's get started, everyone. Hi, my name is Janaki, and we also have Caitlin here. Caitlin, do you want to?
Oh yeah, I'm Caitlin, a tutor.
Great. So we're really excited to run the object-oriented programming review session for you today. So I'll just quickly share my screen and we can get started. The format of this review session will be a set of slides, and we'll be doing some worksheet questions interspersed with it, and then going over the worksheet problems. Both the slides and the worksheets, as well as the solutions to the worksheets, will be posted in the review session material folder that's shared with you. And I'll also post it in this chat in Zoom. If you have questions throughout this review session at any point, please feel free to ask them by unmuting yourself, or you can also ask them in the chat. If there's any questions right now, please feel free to ask. Let me share my screen. Okay. Can I get some thumbs up if people can see my screen? Great, thank you for that. So today's review session is all about object-oriented programming, which might feel like a really, really long time ago for us. So let's review some of the essential concepts around it first. Let's jog our memory by thinking about how we've used object-oriented programming in this course in the past. Anyone have any ideas? Or anyone remember how we've used object-oriented programming in this course before? You can drop it in the chat if you have any ideas. We've used it in ants. Yes, that's correct. We've definitely used it in ants. How else? Anywhere else where we saw object-oriented programming come into the picture? Well, I'll share one example. We used it to create a tree class to represent tree objects, which we started off by defining in a functional data abstraction way, and then we introduced the tree class, which made it easier for us to do certain things. We also used object-oriented programming to create a link class, and that helped us create linked lists, which have a first and a rest object. So those are some ways that we've used object-oriented programming already, but as you know, object-oriented programming can be used to do many more creative things as well. So what is the definition of object-oriented programming? It's a paradigm that allows us to treat data as objects. So anything that I see in the real world, like a flower or a blanket, or a table or a classroom or an emotion or a person, all of these are things that we can represent as objects in Python. We can enforce that abstraction by bundling the behavior of that object, so what that object can do, as well as its attributes, what are the properties of that object, all in a single representation in Python. What else can object-oriented programming accomplish? We can use it to communicate between objects through method calls. For example, in your ants project, you were able to represent ants via a class, and you were also able to represent bees, which allowed you to have them interact with each other in certain ways via the methods that you defined in both classes. You can also create multiple instances of objects. So once I define the ants class, there can be more than one ant. Once you define the bee class, there can be more than one bee. We will also discuss how inheritance works at a later point in this review session, so stay tuned for that. I also just shared the slides to the Zoom chat. They should also be in the folder that was shared with you via Piazza with all of the review topics resources. All right, so that was a brief definition of what object-oriented programming is. Now let's define some of the pieces of code that go into creating objects and classes in Python. So the very first thing is a class. What is a class in Python? It's a template for creating objects So one analogy that a lot of people use to describe classes and objects is the class is like a blueprint for a building, and the object or the instance of the class is the actual building itself. So an instance is a single object created based on a class. Once I create the ants class, if I instantiate it, I can have one single ant, but I can instantiate the class again to get another individual ant. An instance attribute is a special property of an object, which is specific to an instance. So I might be keeping track of the ant's armor for one particular ant, but its armor is different from the armor of the different ant that I created. A class attribute is a property of an object that's shared by all instances of the class. So I could keep track of some common number that all the ants are contributing to. I'm just using the ants project as an example because I think it's something that's very familiar to us by now if we all worked on the ants project. And lastly, a method is an action or a function that all instances of the class can perform. So one thing that bees were able to do was interact with ants in specific ways via their methods. So I'll share an example with you about ice cream because that's going to be the theme for the first half of our review session. So I've repeated the definitions here for your reference, but let's take a look at this example here. The syntax for a class, which is a template for creating objects, starts with this keyword class, and then you have the name of the class, followed by a colon. All the code indented under the class is specific to that particular class. In purple, we have class attributes. So those are properties of a particular object that is shared by all instances of the class. So here I've just initialized a dictionary called colors, where I'm mapping flavors to the colors that they are for ice cream. And this is a class attribute that's going to be shared and accessible by every single ice cream instance that I ever create. I also have class attribute called inventory, which is a blank dictionary for now. Also have two class attributes called freezing point and melting point, which are numbers. And those, again, are shared by all instances of an ice cream. How did I decide to make them class attributes? Well, this is all common information that all ice creams should share. Next thing that we have is a method inside this class. And this particular method is pretty special because it's the init method, which stands for initialize. And we can tell that it's special because it starts with 2 underscores and ends with 2 underscores. As with any method that is defined and created indented under a class, the first spot for a parameter is a special spot because it refers to the object that this method would be operating on. We also have other parameters here, and for the init method, these refer to pieces of information that we need when creating an instance of the ice cream class. So let's skip over the inside of this init method for now, and we'll come back to it in just 1 second. Let's look at the last line first. In this last line, what we're doing is creating an instance of the ice cream class. And the way we're doing that is we're saying ice cream, the name of the class, followed by parentheses, and passing in the flavor and the temperature of the ice cream that I want to create at this point. So what does this line of code do? Well, under the hood, Python sees the name of the class ice cream, and then it says I should look up the init method for this particular class. So it finds the init method wherever it is, and then it executes the init method with flavor bound to flavor that was passed in, strawberry, and the temperature being bound to the number 20 that was passed in. Now, if you're wondering, why did we pass in 2 arguments over here to ice cream, whereas I see 3 parameters listed in the function signature for this init method? Well, that's a good question. What happens is self automatically gets bound to the instance that this line of code starts creating. So under the hood, this piece of syntax calls the init method, automatically creates a new blank object that it's going to start creating and uses the passed in information for everything following self. So once we go into the init method, we see these two lines, self.flavor equals flavor and self.temperature equals temperature. What this does is it saves the value strawberry into an instance attribute, which is a property of an object specific to an instance. Same thing with temperature. It saves that string and that number with respect to self, which we just said was a new object that we started creating. And then we have some pieces of logic here that say if this particular flavor, strawberry, is not in your inventory right now, which happens to be the case, we want to go ahead and create a key for flavor in this dictionary and set it to an empty list. So now that would modify inventory to have the string strawberry pointing to an empty list as its value. And then finally, last thing we do in the init method is we index into the inventory at this particular flavor, strawberry, and append to that list the value self, which appends the entire object that we just created into the inventory. So that was a walkthrough of this ice cream class, which we will be using in problems that we will do momentarily. Before we do them, let's talk about some other types of methods, because we just walked through the init method, which is kind of special, but there's other things that ice cream can do as well. And those come in the form of methods like freeze and heat and melt. So these methods are called bound methods because they're defined indented under the ice cream class. And the way to call them is by saying any particular instance of ice cream dot this bound method, like freeze, and then pass in the parameters that it needs. For example, for the heat method, we need to pass in a degrees parameter, which is like some number of degrees that you want to melt the ice cream by. For freeze, you need no parameters, so you just call it with empty parentheses. You might ask again, why do we see one parameter for freeze, but we should pass in no parameters here when we're calling the bound method? What happens when you're calling a bound method is something special. Python sees a bound method and automatically binds the first parameter in its function signature, which is self, to the instance that the method is being called on. So when you're calling these methods, these bound methods, your job is to only pass in the information that appears after self in the function signatures. I'll pause right now to see if people have questions at this point.
As a quick question, when
Yeah.
we're going through like an environment diagram or what would Python do type question, and they ask us to create a new instance, does that mean that we have to draw a separate class instance part on our table, or do we just go to the initial table where the class is defined?
Okay, good question. So I'll repeat kind of a paraphrased version of the question, which is how do you do environment diagrams for object-oriented programming? And my answer is typically we don't ask you to do object-oriented programming in environment diagrams because we never introduced a formal notation for that. That being said, it is kind of a good idea to come up with a made-up notation for yourself in order to illustrate object-oriented programming code if it helps you walk through the logic, but we won't ask you to do that on an exam. Did I answer your question?
But what would we do in like a what would Python do type of scenario? Not necessarily but where it would be helpful to diagram out this stuff, but we don't necessarily have to. How would we go about
Okay.
doing those types of problems? Because even though that may not be on the upcoming final, it's still good just in case we want to check over work and things and all of those types of things.
Yeah, good question. So how would you represent it just for yourself? And I think we'll have an opportunity to have Caitlin demo a good way to represent object-oriented programming in like an environment diagram style illustration. So stay tuned for that. We have
Okay,
a question.
sweet.
We have
Thank
a
you.
question in the chat. You're welcome. That is asking, when it appends self to the inventory, is it appending all of its instance objects? Okay, good question. So what is happening at this last line of the init method? What is it appending where? So let's go back to the slide where we had ice cream being instantiated, and we were just creating one instance of ice cream. Creating one instance of ice cream just fires off one call to this init method. And so in this one call, we only append the single instance that we just created. This ice cream instance gets appended to the entry for strawberry in inventory. So at the end of all of this code, inventory just has one key, strawberry, which points to one list, which has one element inside it. And that one element is this instance of the ice cream class. You can imagine in the future when I instantiate more ice creams, like I instantiate a chocolate ice cream and a pistachio ice cream and another strawberry, all of those would also have to call the init method when they're being created. And then those instances would also get saved in the inventory under their specific key. Did I answer your question, Brianna? Great. All right. Well, I think it's time to do some problems. So go ahead, visit this URL to find the worksheet for this review session. It has all the problems that we'll be going through. But for starters, let's spend about 10 to 13 minutes working on question 1, A, B, and C. The URL is tinyurl.com/OOP-review-SP20. I also just shared it with you in the chat. So our recommendation for you is to create a copy of this Google Doc, and then you can just fill in the blank as you would regularly for the fill in the blank questions, and you can modify the doc as you want. If you have questions as you're working through this, which I hope you do, please feel free to ask them in the chat or unmute yourself, and we will definitely answer your questions here. So let's meet back around 11:42.
So Anna Maria asked, is flavor just one key within the dictionary? And yeah, so the dictionary will consist of a pairing of keys to like an integer, where the integer represents how many ice creams have that flavor. Yeah, so flavor is the key, and what it's mapped to. Um, maybe a better way to explain it is, I think, so in the inventory dictionary, the flavor is a key that maps to um, the number of ice creams that have that flavor.
Or rather, the flavor is a key that's a string, and it maps to a list of all of the objects that were created of that particular flavor. So yes, the length of the list would give you the number of objects that match the particular flavor. We also have another question: does the eater class inherit from the ice cream class? So the eater class does not inherit from the ice cream class in this particular code. Well, let's take about 5 more minutes to work on this. I know it's a little bit quick, um, but once you are ready to review the problems, can you raise your hand via the Zoom feature? I think you have to click participants and just raise your hand. So I'll get a measure of how many people are ready by how many people have their hands raised. Okay, we have a question. Where is ice creams defined? I'm guessing that this is regarding part B, probably number 8. So it's not defined anywhere previously, but it's a variable name that you're using as you write the for loop. So if I'm writing a for loop to iterate through a list 2, 4, 6, I can say for x in 2, 4, 6, even if x hasn't been previously defined, and x will in turn get set to the value 2, and then the value 4, and then the value 6 in sequence. Did I answer your question? Okay, great. All right, and that was a very timely question. Thank you for that. I think several people have raised their hands. So let's go ahead and review it together. Even if you didn't finish, that's completely fine, because I don't think we gave you quite enough time to finish, because this is an accelerated review session, just so we can pack in a lot of content. I think it's also a good time to announce that this session is being recorded and hopefully will be posted to YouTube after this session is over. So let us go over this review. So let me go ahead and make a copy of this, where I will write out the solutions. All right. So let's start by reviewing question 1. And because this is a fill in the blank question, I want to get you all participating. Once we start question 1, go ahead and write in the chat what you think the blank should be, and I'll give an explanation, and then we'll move on to question 2, etc., etc. Okay, so for the first blank, where it asks you to update the inventory with this particular ice cream, what piece of code do we think should go here? Yes, we want to add in a value to the dictionary. We have Ken saying ice cream.inventory, index.flavor, append self. Great, yes, and as a hint, this was mentioned a little bit in the slides. So good, thank you for all the people who are sending their responses. So over here, just to resize my window, we can say ice cream.inventory indexed at flavor, which will give us some sort of list, because our inventory maps string flavors to lists of the ice creams themselves. So we want to append the newest ice cream that we've created, and the way we reference the newest ice cream we've created is with the variable self in this init method. Self is a variable that exists in this init method context and refers to the instance of the ice cream class. So we have a question, why do we use .append self? Great question. We use .append self because of the way our inventory is set up. So the goal for this inventory is to map flavor strings to lists of ice cream instances for that particular flavor. Okay. Does that kind of clarify your question for the person who asked this? Great. So that's the goal for the inventory, and that's the first blank. Okay, what do people think should fill in the blank for the freeze method, where we need to set it to the freezing point? How do we figure out what to put here? Am I asking you all to do some research and figure out what temperature ice cream freezes at? Or is there another way we can refer to the freezing point of ice creams over here? Well, it turns out that we have information about the freezing points of ice cream stored as a class attribute. So under the ice cream class, we define this freezing point variable to be set to the value 10. So all ice creams apparently freeze at 10 degrees Celsius, or whatever unit this may be. So yes, thank you for everyone contributing their ideas. This should indeed be ice cream dot freezing point. Why is the ice cream dot freezing point? Well, one way to refer to class attributes is to say the name of the class and then the value of the variable for the class attribute. Question, could it also be self.freezing point? Yes, great point. We could also say self.freezing point. Why is that? Because self is an instance of the ice cream class. So the very first thing that Python will do is it will check, does self have some attribute called freezing point? And it'll say, no, there's no instance attribute called freezing point, but there is a class attribute for the class that it belongs to, which is the ice cream class. So you could do either. You could say self.freezing point, or you could say ice cream.freezing point. All right, let's take a look at the next blank, which asks us to update the temperature inside the heat function. So heat gets the variable self, of course, and then it also gets a number for the degrees. How should we update the temperature of the ice cream? Well, where is the temperature of the ice cream stored in the first place? We can check out what sort of attributes, instance attributes an ice cream has as flavor, and there we go. It has a temperature attribute as well. So we want to update this temperature attribute. So when you heat ice cream, will the temperature go up or will it go down? Turns out that when you heat ice cream, the temperature will go up. So we can say self.temperature, which is the attribute, instance attribute that we want to modify. We want to set that equal to whatever it was previously. And then we want to add the amount of degrees that got passed in. So we're increasing the temperature by the amount of degrees. And yes, one nice way to do this in shorthand is to just say self.temperature plus equals to degrees. So it will figure out what is the current value of self.temperatures, add degrees to it, and store that value back inside the self.temperature attribute. Okay, set to melting point. So similar thing to what we did for the freezing question, we can go ahead and set it to not the freezing point, but the melting point. Next thing, remove function, the remove method. We want to remove this ice cream from the inventory. So again, this is a method defined under the ice cream class that can operate on a particular ice cream. How do we refer to the inventory in order to remove it? Well, the inventory is some class attribute, ice cream.inventory. Yes, thank you for the people sending me responses via the private chat. So we do refer to it via ice cream.inventory. How do I remove it though? Okay, well, one thing I can do is I can say ice cream.inventory. Where inside the inventory dictionary will this particular ice cream be stored? It will be stored under the flavor, key. So flavor, how do we refer to the flavor of this particular ice cream? I can't just say flavor because that's not defined in the scope. I have to refer to the flavor of self, which I can do by saying self.flavor because flavor is defined as an instance attribute over here. And then I can do .remove self. .remove now, in this case, I have a question for you. Is this a recursive call or is it not a recursive call? What do people think? Say in the chat, recursive or not recursive? People are saying not, it's not recursive, right? Yes, you are correct. It is not recursive because ice cream.inventory index.self.flavor gives you a list. And we're calling the remove method of list objects. So we're removing the element self from that ice cream list. Okay, part B. I'm going to kind of breeze through this because I still want to give us enough time to do some of the other questions and do some other practice questions as well. So we have this eater class now, and eaters have a name, they have some sort of appetite, they have a favorite something, they can also be picky or not picky. So a picky eater only eats their favorite ice cream flavor and wants the coldest ice cream flavor available. Any other eater would typically be happy with the coldest ice cream, regardless of the flavor, unless they have a craving. If an eater has a craving, then they behave like a picky eater. So this is a lot of information in this doc string. So this is an exercise in trying to parse out which information we need to figure out what piece of information. Number 6, how do we know we are out of their favorite ice cream flavor? Fill in the conditions. So we need to fill in the conditions to figure out whether we have their ice cream flavor in stock or whether it's not in stock. So how do we know about which ice cream flavors we have and which ones we ran out of? We should consult the ice cream inventory dictionary, which is, again, our class attribute where we've been updating what we've been updating with each time we create a new ice cream. So I need to check if this particular eater's favorite flavor is in the ice cream inventory or not. So now choose is a method that's inside the eater class. So self refers to an instance of the eater class. So how do I get my favorite flavor? Well, we have an instance attribute called favorite. So we have self.favorite. I need to check if self.favorite still has ice creams in stock in ice cream inventory. So if I say self.favorite in ice cream.inventory, that will tell me that true, self.favorite is in ice cream inventory. But the question it's asking is, how do we know we are out of their favorite ice cream flavor? So we want to say true if we're out. So we have to reverse this condition and say self.favorite not in ice cream inventory means that we're out of their favorite flavor. What is another way that we could be out of their flavor? Well, it could be possible that I have a customer who is asking for cookies and cream ice cream, but I've never created a cookies and cream ice cream in my life. So how would we represent that? We could just say ice cream dot inventory indexed at self dot favorite oh, sorry, that's not the condition that we're doing. The condition that we're covering is if that was the previous condition that we wrote. So self.favorite is not in ice cream.inventory. And now this is the case where we're out of their particular ice cream. So we could index in at ice cream.inventory at self.favorite and just say if that list is empty. So we can reverse that by saying not ice cream.inventory index at self.favorite. So we have some questions. Can we put not in ice cream.inventory indexed at flavor? So in this case, for the person who asked that, flavor is not defined as a variable in this context because this is the choose method, which is inside the eater class, but you're very close. I don't understand the distinction between two cases. Thank you for asking. Let me clarify that up. So the question is to write out a case for how do we know we're out of their favorite flavor. So there's two things that could happen. One is that the entry for that flavor in our inventory will map to an empty list, which means that we're out of that flavor. Or we've never created that flavor before, which means we don't even have a key for that flavor in our inventory dictionary. So this is the case that means that the flavor maps to an empty list because we're saying ice cream inventory indexed at self.favorite gives you an empty list. So saying not of the empty list would give you true. Or self.favorite, which is your favorite flavor, for example, cookies and cream, could not be in the ice cream inventory at all. Did that clear it up a little bit? Great. Okay, number 7, if they're picky or have a craving and we're not out of their favorite flavor, what are their choices? So here we did, if we're out of their flavor, then you should just like print something, some statement over here. But if we actually do have their flavor in stock, we need to set choices to a list of all of their options. And this is the case where they're a picky eater or they have a craving. So according to our documentation, our doc string over here, it says a picky eater only eats their favorite ice cream flavor and wants the coldest ice cream available. So they only eat their favorite ice cream flavor means that we should check in inventory for what are the options for their favorite flavor. So I should say ice cream dot inventory indexed at self dot favorite. Yes, Ken, that is absolutely right. So that will be a list of their choices because picky eaters only eat their favorite ice cream. So now if they're not picky and do not have a craving, how can you build their list of choices? What can you iterate over in the line below? So if they're not picky and do not have a craving, according to our options over here, any other eater typically would be happy with the coldest ice cream regardless of flavor. So we might have many, many flavors inside our inventory. So we should try to iterate over the pairs in our inventory dictionary. So I would like to iterate over something like strawberry and all of the instances of the strawberry ice cream, chocolate and all of the instances of chocolate. So the way we do that is by saying ice cream dot inventory, which is a dictionary, and then say dot items. What items would give us is an iterator or an iterator-like object that would have pairs of the key and the value. So we have a question, is choices still all just one flavor but different temperatures? Kind of confused on what the choices list is representing because they can only have one favorite, right? Yes, they can only have one favorite. So in the case that they're picky, the specification is that picky eaters only eat their favorite ice cream, so their choices should only consist of ice creams of their particular favorite flavor. If they're not picky, even though they have a favorite ice cream, it looks like they're open to having ice creams of any flavor. So far we haven't figured out the temperature part yet. The temperature part will come later. Right now we're just listing out all of their options based on flavor. Thank you for that question. So when we iterate over this, every single time through the for loop, flavor will get bound to a particular flavor like strawberry, and ice creams will get bound to a list of ice creams of that particular flavor. So it'll be strawberry and all the strawberry options. Next time through, it'll be chocolate and all the chocolate options. And we're going to be extending the choices list with the ice creams at each turn. So we're going to build up a list with all the ice creams that are in your inventory. Items gives us the list we want to loop over. Yes, I would recommend try to create a dictionary in your Python interpreter and do dot items and see what it returns. And then try to iterate over what it returns if you would like to review what a dictionary dot items does. We have a couple more questions left, 3 more for this. If choices. Think about what this condition is checking. Recall that a non-picky and non-craving eater wants the coldest ice cream regardless of flavor. How do you get the coldest ice cream from choices? Okay, so now that we've built up our choices dictionary for picky eaters and also for non-picky eaters, we want to get the coldest ice cream. How do we get the ice cream which corresponds to the lowest temperature? So here is a good opportunity to, yes, use the min function and a lambda key. Thank you for putting that in the chat. So what we're going to say is we're going to say min, and we want the minimum out of the choices list, but min has an optional parameter called key, and we want to sort through choices based on their temperature, right? So in our lambda expression, we'll look at one choice at a time, and the criteria that we want to use to sort that choice is its temperature. So each choice is an ice cream object. So if each choice is an ice cream object, how do I grab its temperature? Well, each ice cream object keeps track of its own temperature via an instance attribute. So I can just say choice.temperature. So what this will do is it will sort through choices based on each choice's temperature. And the first element of choices will have the lowest temperature ice cream. And so taking the min of that will give you that lowest temperature ice cream, and that will be stored in chosen. People are asking, when should I use key? What does the key part of min do? So the key part of min is a function that takes in a parameter that corresponds to a single element of the list that you're iterating over. The job of this lambda function is to give you the criteria that you should use to be sorting this list or getting the min of it. Why isn't it self.temperature? Does choice separate all instances? Good question. So what does self refer to in this function? This function is a method defined in the eater class. That means self is some eater object. For example, we define this eater class. I could have instantiated an eater instance, like eater with the name Janki, with a particular appetite, particular favorite flavor, etc. And then I could call the choose function on Janaki. So calling the choose function on that in this context would have self referring to that Janaki instance. So saying self.temperature would error because I do not have a temperature attribute over here. Next question someone has is, what would you say would be the best strategy to follow to attempt object-oriented programming? Okay, hopefully we'll get to that towards the end of this section, so stay tuned for general study tips. But one thing that I can say is to do more practice exam questions, which is the plan as soon as we get through this. Okay, number 10, what does the above docstring say? Translate that condition to below. An eater can only eat if they have a positive appetite, or in other words, an appetite greater than 0. Okay, so I need to check that an appetite is greater than 0. Something is greater than 0, but how do I get my own appetite? Well, I have reference to self over here, and self has an appetite instance attribute, so I can say self.appetite is greater than 0. Next blank, what method from the ice cream class should you call below? So this is checking if the appetite is greater than 0, we choose our craving by saying ice cream equals self.choose, which calls our choose method, and ice cream is set to the ice cream that we've chosen. If ice cream, this checks that ice cream is not none, what method should we call below? Eaten. So we want to make eaten set to whether it's been eaten or not. And what we should do is we should see, what are the methods that I can call on ice cream class? Well, I can freeze the ice cream, heat the ice cream, melt it, or remove it. Well, if I'm eating the ice cream, then it makes sense that we should remove it. So I can say ice cream dot remove, and that will remove the ice cream from the inventory because it's been eaten already. So I don't want to keep track of it in my inventory because I've given it away to an eater. So we have a question, isn't craving a Boolean? How does it take in the flavor choice, or is it not just true and false? Yes, craving is just a Boolean. So craving doesn't take in the flavor choice. The flavor choice is set by the preference of the eater in the favorite attribute. We do not need to pass an in for inventory method. So I'm not sure what inventory method means, but ice cream.remove is calling remove on ice cream, which is an instance of the ice cream class. And you can check out what are the different parameters that it takes in. It only takes in self, which automatically gets bound to the instance that it was called on. Another question is, how is self.choose working? Yes, great question. Self.choose. So self is an instance of the eater class. Choose is a method of the eater class as well. So what it does is it calls the choose method and binds self over here to this instance self. And it passes in craving, which is true or false for this craving parameter, which is by default set to false. last blank. Okay, we made it almost through this ice cream situation. So if the ice cream has been eaten, we print out some string over here, and then we should update the appetite. So an eater can only eat if they have a positive appetite, or in other words, an appetite greater than 0. Eating 1 ice cream should decrease the appetite by 1. You know, usually in exams we'll make it clear what you have to do, I think. But I think I wrote this a while ago and I was just assuming that self-appetite would be decreased by 1. So that is that for the ice cream part. We won't go over C, we won't go over D together, but we will post their answers in the solution. So now I'm gonna hand it over to Caitlin to talk a little bit about inheritance, and I can continue presenting, and let me know whenever you want me to unshare, Caitlin.
Yeah, so real quick, we're gonna go over inheritance. It's just, inheritance is a extension of OOP. So a lot of times we'll have things that are like, maybe we'll have classes that are very similar to each other and differ in like maybe behaviors or like certain attributes. If we were to code these two things separately, we would have a lot of code repetition. So one way to reduce code repetition is through inheritance. So with inheritance, you can designate one class to be like, we call it the superclass. And the class that inherits from it is called the subclass. Subclasses inherit attributes and methods from parent classes, and we can also override certain behaviors of parent classes. So for example, here we have the vegan ice cream class, and in parentheses we have ice cream. So this tells us that the vegan ice cream class is a subclass of the ice cream class. In addition, I think we've updated the freezing point and melting point fields, which is why they're here. And then we also have updated the init method. Notice in the init method, we call ice cream's init method because vegan ice cream is ice cream, right? So we still want to like have all the same things that ice cream has. So we'll initialize them using ice creams in it. And then we'll add one other instance attribute, and that's the base. Yeah. Yeah, so we would instantiate like vegan ice cream in the same way that we instantiate any other class, just by calling the constructor with the class name. Yeah, and you'll notice that like vegan ice cream doesn't have like any other methods that ice cream does. However, when we could call these methods on vegan ice cream just the same, because if we don't find the method in the vegan ice cream class, we'll look at the ice cream class. And so we'll use ice cream's methods, and we call that like inheriting methods because we don't need to rewrite them. Yeah. Any questions on inheritance? I know that was a little fast. Okay, if that's the case, 1D was on inheritance, but for the sake of time, we're going to skip over it. Solutions will be posted later. And for now, let's get started on some exam practice questions. So let's take maybe 6 or 7 minutes for question 2, and then I'll go over it.
So we got one question in the chat, which was, will vegan ice cream have the exact same properties as ice cream? Caitlin, do you want to take that question?
Yeah, so it would depend on the implementation. So for example, I think the freezing and melting points are a little different with vegan ice cream. So if we said vegan ice cream dot freezing point, we would get 10. Oh, sorry, those are the same. If, for example, we had changed them to be like, the freezing point was like 12 or something, if we said vegan ice cream dot freezing point, we would get 12, not 10. However, if we, for example, say we like omitted one of these fields, like we just didn't redefine what melting point was, if we said vegan ice cream dot melting point, because we don't have it in this class, we're going to look at what ice cream's melting point is, and it would be 31.
And that's because ice cream is the parent class of the vegan ice cream.
Yeah. If you want to think of it in terms of like environment diagrams, almost, it's like the parent frame. Just how you would look up attributes in parent frames, you would look up attributes in parent classes. Okay, I think I'm gonna go over the solutions now for the sake of time, just so we have time to get through one more exam practice problem. Let me share my screen. Can everyone see that? Okay, so question A is asking us to implement the poll class and the tally function, which takes a choice C and returns a list describing the number of votes for C. This list contains pairs, with the first thing being the name of a poll, and the second thing being the number of times the specific choice was voted for at that poll. And we can assume that all poll instances have distinct names. So let's start off looking at the poll class. We notice that poll has a class variable called s, and we don't really know what that's for yet because s isn't a very descriptive variable name. So we'll come back to that. First thing, we're going to initialize a poll. Does anyone have any ideas for what self.name should be? Oh. Yeah. Yeah. Oh, sorry, I should have gone over the. So we see here that there's a doc test for like how we actually create polls. It looks like we pass in a string to be the name, and that variable is n. So we're going to set self.name to be n. And we also have a dictionary for storing the votes. So it'll likely be, we're going to store what we're voting for with the number of times it's been voted. And this line we'll come back to, and I think it'll make a little more sense once we actually do tally. So now for vote, we want to update the number of votes that we have every time that we are given a new choice for this polling machine. So is there an attribute that we should be updating here? Yeah, so we should be updating votes, right? So, well, okay, well, if we just say self.votes, that's just the dictionary, right? We need to update a specific value for a specific choice, right? So to get that, we're going to update our value for choice. But what should we update this value to be? Okay, so the first thing we need to consider is, okay, so we might, like in our dictionary, we might have like, okay, like dog is like 1 and like cat is 2, right? So we could have 2 scenarios here. Either the thing we vote for is already in the dictionary, and we, like, if we vote for dog again, we should change dog to be like 2, right? Or we could vote for something that's like not in the dictionary at all, right? We could vote for like bat or something, right? And since bat isn't in the dictionary, if we just say like votes choice +1, if we do this for something that's not already in the dictionary, we're going to get an error. So in order to get around that, we're going to use the dictionary get default method so that we're going to get the existing number of votes for that choice, if it exists, and then add 1 to it. But if it doesn't exist, we'll just return 0 and then add 1. So therefore, if bat didn't exist in the dictionary before and we decide to vote for bat, it'll actually update correctly and we'll get this in the dictionary. All right. And we'll still come back to this line after we tackle tally, because I think it'll make a little more sense why. So for tally, we're asked to, like, after we create all of these poll objects, we're asked to tally the number of votes. Oh, sorry, yes, that is get choice +1. And yeah, so, oh, yes. Thanks, Brianna. It should be self.votes.get. I just forgot. So the reason we have to use get with the default is because you can also access values in a dictionary by like indexing into it, right? Like that. But this errors if choice isn't a key in dictionary in votes already. So in order to get around that, to avoid erroring, we use get with a default value. because even if we're voting for something that hasn't already been voting for, we still want to update the dictionary correctly. We don't want to just throw an error. Yeah. Any other questions about poll so far though? The +1 increments the votes. So it's kind of like if in our dictionary, let's say we voted for dog once already and we voted for cat, right? If we vote for dog again, we would want to change this 1 to a 2, right? Because we're mapping the thing we're voting for to the number of times it's been voted. And so this +1 is what changes it from 1 to 2. Yeah. All right. So moving on to tally. So basically, we'll create a whole bunch of poll objects, and then we want to tally the counts for a certain choice across all of the poll objects. So I kind of like to diagram my OOP problems. So for this doc test specifically, I'll draw 3 boxes representing each of the poll objects we've created. I'll call it A, B, and C. And we know that each poll object has a dictionary of votes. So if we tally up each vote, we'll get, okay, C voted for dog once, A voted for dog twice, A voted for once, and B voted for cat once. Okay. And we want to somehow return, so if we say tally dog, we want to return A2 and C1 because those are the poll objects that have the choice we're looking for, and we return the vote counts for them. Now, the issue is, how do we get access to all of these poll objects at once? And the answer lies with this class variable. Do you guys have any ideas for what we should do to make sure that we can access all of the initialized poll objects from the poll class? Yeah, so someone said we should append votes to S. We're on the right track. We do want to append something to S. So, but we don't want to append just the votes because then we lose the name of the polling object, right? And remember that we do need to output the name of the polling object in tally. So do we have something that encompasses both the name and the number of votes? So much like how we, so someone said get, not quite. So if we think back to the ice cream problem and how we had an inventory that we appended ourselves, the ice creams to, this is a really similar idea to that. We're going to append ourselves to this list such that each time we create a new poll object like this in the poll class, we'll have a poll.s will actually point to a list of these poll objects. And so this allows us to iterate through each of these poll objects and check whether or not we have the choice we want in this poll object. Oh yes. Sorry, just to clarify, because S is a class variable, we'll have to access it using poll.s.append. Yeah, any questions so far? Okay, so moving on to tally. So now that we know that we can access all of the poll variables in poll.s, right? How should we iterate through each poll and only output polls that have the choice that we're looking for? How does it contain the votes? Oh, are you talking about for the poll.s.append self line? Because polls, like the self that we're appending is a poll, right? Poll has votes. We can just say, if we said like self.votes, that would be the votes, right? So by appending self to the list, we're actually appending information about both the poll's name and the votes. If it helps, I like to kind of think of it as like objects are like one big box that contains a lot of information. So just like how I drew it below here, each poll contains the votes it has. Yeah. Okay, so back to tally. So the fact that they only give us one line for this method is kind of a hint, and especially because we're asked to return a list, that's kind of a hint that we're wanting to use list comprehension. So for each poll in the list of polls, we're going to want to get, we only want to look at each poll if it contains the choice we're looking for, right? And we know that with list comprehension, we can filter using the if clause. So what should the condition be? So for example, P equals C. Yes, you guys are on the right track. So C is a choice, right? So let's say, for example, is tally and dog. So we're going to be looking for polls that have dog, that dog has been voted for, right? So it should be if C in, so note that we found some specific poll object P. How do we check that like C has been voted for in P? Greater than one? Yeah, so that, so someone said, yeah. Yeah, remember that polls have both a name and a dictionary of votes, right? So if we can say that C is a key in votes, then it has been voted for in P, right? So we can say, right? If choice C is a key in P.votes, then we want to look at it, right? Yeah, exactly. And then finally, what do we want to do now that we're going to get every poll that has the choice we're looking for? What do we need to output? So we know that we want to output a list of tuples where the first thing is the name of the poll and the second thing is the number of votes for the choice that were given. So someone said we want to output the key and the value. Yeah, for the second part, we definitely want to output the value. Is P.votes looking? Yeah, so this if statement is looking in P.votes to see if the choice has been voted for. Does that choice exist in this polling machine? Okay. Okay, for the sake of time, I'm going to like try and go a little faster. But basically, since we want to output a tuple for each polling machine, and we want to output the name of the polling machine, so we'll say p.name. And then finally, we want to say, how many times has this choice been voted for? So for example, if we want to tally dog on A, then we know that dog has been voted for 2 times because that's in the dictionary. Yeah. So we're going to say p.votes.c. Okay. So this is the final line of code for tally. Are there any questions?
All right then. So since we're right about out of time now, I do want to say thank you to everyone for showing up. If you have time, we would really, really appreciate it if you can share your feedback with us about this session. I'm sharing the link in the chat. It's tinyurl.com/OOP-feedback. In the last few minutes, kind of running over time, I wanted to share some general tips about object-oriented programming, question problem solving, because someone asked this earlier. I would say one thing, like with all problems that you'll have on the final, is focus on reading the instructions really carefully and parsing them to identify specific pieces of information. For object-oriented programming questions specifically, the pieces of information that you should be on the lookout for is what are pieces of information about particular instances. So a particular object of this class needs to keep track of some piece of information. If that's said in the instructions, you should immediately think, okay, that might be an instance attribute that I should be keeping track of. If in the instructions there's some information about something that is kept track of across all objects of a particular class, you can immediately think, okay, that has to do with a class attribute. If the instructions specify something that those objects can do, you can think towards bound methods that are defined under the class. And one common pitfall that I can think of that students encounter when doing object-oriented programming problems on exams is not expressing clarity about what self is referring to within a particular method. A lot of times, object-oriented programming questions on exams have multiple classes, and you should keep track of what class is this bound method defined under and what does self refer to here. So be very clear on that and know what attributes and methods that self object is capable of doing. Those are my general tips for object-oriented programming. I will stick around, and I also made the solutions public. So you can take a look at those. They're linked now at the top of the worksheet that we just did together and in the folder as well. So if there's any remaining questions, we'd be happy to help answer them.
I have a quick question.
Yes.
So as a general strategy, you would say read the instructions carefully, identify specific pieces of information, and then just figure out what you need to do and then go ahead and write it out.
Yeah, definitely. And between those two steps of reading information and figuring out what code to write, definitely run through the doc tests like Caitlin did here, because that will help you clarify what methods belong to what objects and what are the outcomes of those methods, so you can reflect that in your code precisely.
Okay, cool. Thank you guys so much.
You're welcome. Thank you.
I have a quick question on
yes.
like for these questions, like the dictionary part kind of confused me on like what it contains. So like how do you go about like trying to understand that?
What the dictionary contains for this midterm elections question?
Yeah.
Yeah, so in this case, I guess it's not explicitly stated in the problem statement what votes was supposed to contain, but it kind of follows that, well, we don't want to like repeat choices, right? So because we want unique choices, it kind of follows that we should map the choice that we're making to the number of times it's been called. I guess in this question, it wasn't really clear from the question statement what exactly votes was supposed to be, but I think like the general use of the dictionary is good for like keeping track of unique occurrences of an item. So in this case, that's why it seemed natural to just use votes and update the number of times each choice has been called. I'm not quite sure if that answered your question, but that is generally how I.
Oh, sorry. Okay, thank you. So like, I think like I get confused on like just in general like with problems like these like what dictionary is supposed to do, like the ice cream one. Like I was confused on what the dictionary contained for that one as well. Like, do you have any tips to go about it, like understanding it?
I think it depends a lot on the problem and the context. So with the trying to remember, wait, Janaki, for the ice cream one, was the dictionary already defined, or did we have to redefine it?
Yeah, so we can figure out what goes in the inventory dictionary by really looking carefully at the init method for the ice cream class, because the ice cream class is where you're modifying the inventory each time an ice cream gets created, right? So looking at the particular line where it says ice cream.inventory indexed at self.flavor tells you, okay, so the index, if we're indexing into the inventory at a particular flavor, that means that the keys of this dictionary must be strings that are flavors. So you have one piece of information. And then you look at the right-hand side of the equal sign to see what is the type of information we're storing in the values of this dictionary, which ends up being a list. And we're adding to that list each time the objects, because we're appending self each time we go through the init method. So in that way, you can create a model in your mind of what are the pieces of information that are in the keys and what are the pieces of information in the values for a particular dictionary. So check to see where that dictionary is getting updated or where you should be updating the dictionary in this midterm elections type of problem.
Okay, thank you so much.
You're welcome. All right, I'm gonna stop recording, but I'll still hang around for a couple minutes to answer your questions if you have any.